Okay, first of all, let's find log base 2 of 7. Well, we did this in class, you have to write it out. Let's see. Log base 2 of 7, we know that log base b of x is log of x over log of b. So if I write log base 2 of 7, then b is 2 and x is 7. So we're going to do log of x, which is log of 7, divided by log of b. It's always the log of a base in the denominator, the log of this number. And we punch that into our calculator. When we do, we get something very close to 2.8. We could also, and we did it, do natural log of 7 over natural log of 2 and punch that into the calculator. Comes out exactly the same. That's why I say you can do it this way or you can do it this way. It doesn't matter if you use the log key or the natural log key, as long as you use the same one both times. You don't want to do a log in the numerator and a natural log in the denominator. It's either log of x over log b or natural log of x over natural log of b. Okay, so we get this. Now that makes a certain amount of sense because the inverse to log base 2 of 7, inverse relationship would say that the base 2 raised to the 2.8 power is equal to 7. Okay, does it make sense? Well, 2.8 is close to 3. 2 raised to the third power is 8. So 2 raised to a power a little bit less than 3 equals 7, which is a little bit less than 8. Makes perfectly good sense. And of course you can punch it into your calculator and see that it works out. Now, one comment. This is 2.8 is an approximate value. Now it's a pretty good approximation. I think it's like 2.800 something. Okay, so it's 2.8 is a pretty good approximation, but it's only an approximation. Even the 12 decimal places your calculator would give you is only an approximation. This is the exact value, so I'm going to emphasize this is exact. And this is approximate. And that's important because if you're asked for the exact value, you don't want to give a decimal value, unless that decimal value happens to be accurate, it happens to be exact. There's the exact form of log base 2 of x, and that's as exact as you can get it. Okay, well then we went on to find log base 3 of 4. And it's pretty clear. Now, I didn't write it out when we were doing this, but that's just log of 4 divided by log of 3. And you can punch that into your calculator. Now, let's see. 3 to the first power is 3. 3 to the second power is 9. So to what power would you raise 3 in order to get 4? Probably closer to 1 than to 2. If you do log of 4 divided by log of 3, I'm going to guess that you get something around 1.3. Okay, it could be off by a tenth. It might be a little lower than that. Could be a 1.2, but I think it'll round off to 1.3. Okay, now don't put a lot of stock in what I think. I'm not, like 60-40, 70-30 sure of that. Okay, and I could be way off. Okay, log base 7 of 3. What is that? Well, that's log of 3 over log of 7. Okay, now log of 3 is going to be less than log of 7. So this number is going to be less than 1 because 7 to the first power is bigger than 3. Okay? So it's probably going to be around 0.6. Now you can figure it out. Now, log to the base 6 of 36 is 2. That's because 6 raised to the second power is 36. And you can understand what I'm saying by looking at how this works, okay? Log base 6 of 36 is 2. Okay, that says log base 6 of 36 is 2. X would be 2, C would be 36, and B would be 2. Well, I said it wrong, okay? Log base 2 of 36 is, and I'm not saying it right, it's log base 6 of 36. Log base 6 of 36 is 2. I had too many 2's in there. So I had trouble getting that out, I apologize. Okay, so b is 6, c is 36, x is 2 in this expression. Now, c is 36, so you get 36 here. b is 2, you get, b is 6, I'm sorry, you get 6 here, and x is 2. So this says 6 to the second power equals 36, just what I wrote here. If you turn this around, it's in this form, you get this. Identify b, c, and x, and just write out what you have. And what it comes out to is, it's going to be this to this power equals this. And 2 to the 2.8 power equals 7, as we put it here. Okay? Well, that's how we evaluate logarithms of this type. Next, we'll look at a few logarithmic equations.